This is the last piece in the surveillance pricing pipeline. Supermarkets have been deploying surveillance tooling and creating customer profiles for the last decade without any way to unify those insights until now. I've been playing around with a microcontroller project to monitor my home server with the e-ink display. And coincidentally, in my last visit to my local supermarket, I noticed they were replacing all of the price tags with e-ink displays. These displays are referred to as electronic shelf labels, or ESLs, in the industry. I was curious about the setup and cost of all the ESLs because my dev e-ink setup was around $30, so I was wondering if they could be a cheaper option for production applications. This led me to find the make and model of the ESLs that the supermarket used, which are the Hanshow Nebular Pro Series. Based on the secondary market prices, I imagine these Pro models could be around $5 for a small display. Given an average supermarket has around 3,000 SKUs, decking out a whole store would cost over $150,000. That's not a small investment for an industry with notoriously slim margins, especially when you consider an employee might make $20 per hour. These ESLs really save 7,500 hours of time. Also, why would they outfit the whole store with them and not start with the perishable items, like in the dairy and meat section? The obvious long-term use case for ESLs is to raise revenue through dynamic pricing. They help bridge the gap between the traditional static pricing of supermarkets to the ultra-dynamic pricing of online shopping. This dynamic pricing is further enhanced by everyone's favorite technology, facial recognition. We've gotten so used to algorithmic pricing that Amazon has institutionalized and have come to expect it when shopping online. Dynamic pricing is so ingrained, Amazon has even commoditized it as a service to sellers through its automate pricing feature. Beyond generic dynamic pricing strategies, surveillance information like browsing history, purchase history, and geography can be applied for additional targeting. Pricing strategies from the e-commerce industry are already spilling over to supermarkets through services like Instacart, where in-app prices can be dynamically controlled and items can be more expensive in-app than in-store. The bridge between e-commerce shopping and targeted dynamic pricing in stores will start with pricing by simple metrics like inventory, demand, date, and time of day. This type of dynamic processing is not targeted and will mainly be based on seasonal and daily trends. These price fluctuations will include things like increasing the price of chips and wings in the days before the Super Bowl and increasing prices after work but before dinner. At this stage, it is very hard to notice the changes in pricing since patterns would be hard to pick up on if customers are not shopping very frequently. This stage is similar to the current dynamic pricing that stores implement with physical tags and can be implemented on a larger scale with ESLs. Also note that going forward, whenever I refer to increasing prices, this is a simplification of how supermarkets manage prices. Stores will rarely increase a price. Price changes take the form of tuning the sale price up and down while keeping the regular price artificially high. To demonstrate the sale effect, we can see that this vegetable juice at my local supermarket has 3 different prices displayed and seems designed to obfuscate the price the shopper will pay for the item. If you have a card, do you buy 5 or more to get the $3.49 price? If you don't have a card, do you pay the $4.49 price or the $4.99 price? The next phase of dynamic pricing will involve targeting groups of customers through integrating facial detection with camera feeds on self-checkout stations and store entrances. Shopper facial information can be indexed and linked to a shopper card using machine learning. I'll demonstrate how this is possible with my own e-ink display and facial recognition models later in this video. Shoppers will be categorized as they enter the store, which will be fed into a model to determine prices. For instance, a shopper could be categorized by their previous purchases, then the category information can be used to update a specific aisle or even specific items. This could play out in scenarios like these. Based on your recent purchase history, you and your fellow shoppers are categorized as new parents. You're in a time crunch and you're still not familiar with the standard prices of items. Usually the Kroger brand is cheaper, but the name brand next to it looks more competitive today. The Kroger discount was reduced to nudge you towards the name brand purchase while you're still forming your shopping habits. With teams dedicated to working on these models, stores will develop much smarter and much more nuanced ways to maximize your spend than what I've outlined here. At first, stores will try and hide these price changes by using targeted aisle updates and optimizing the number of price changes throughout the day. If shoppers do wise up to price changes, they have little power to dispute the changes, since the ESL will still show the updated price, which is in sync with the store's pricing database. By pretending that the prices don't change at first, the stores will get us used to the unspoken rule that prices change. We'll know the price is changing, but the stores will deny that they're changing, and they'll know that we don't believe them. Eventually, in-store dynamic prices will just become widely accepted as another piece of our daily lives that has become enshittified. From the supermarket's perspective, this targeted dynamic pricing feature is completely reasonable to implement with proper data management and the capabilities provided by the ESLs. In my day-to-day job, I do data and machine learning engineering consulting, and I have some insight into what the architecture of a basic setup might look like. First, we'll see how easy it is to set up a facial indexing pipeline. This is a well-established pipeline and consists of sampling the video feed to capture frames to be processed. Then a facial detection model can be used to isolate the individual faces in the photo, which are then normalized and aligned. Lastly, a facial embedding model can be used to save the embedded face vectors to an index. The same pipeline can also be used to search future customers against the face index. Indexing faces has become a standard machine learning task and is even commoditized by services like AWS Recognition and open source libraries like DeepFace. To illustrate how easy it is to create these pipelines, I created a simple example where, based on a video feed and facial detection, I changed the sale price shown on an e-ink display. Every 10 seconds, a photo is taken, and if a face is detected in the video stream, it is sent to the server. Once on the server, it's compared against an index of faces to find the closest match and determine the shopper category. While this is going on, my microcontroller is polling my server to check for changes, and if it detects a new shopper category, I update the price. Similar pipelines are already in place at supermarkets, to track persons of interest, at airports used by the TSA, and for ticketing and monitoring of sporting events. With the facial indexing pipeline in place, it's trivial to tie index faces to an identifier at checkout through a membership card. A crude pipeline could use the time of checkout, the kiosk identifier, and the card from the transaction to link a membership card to an indexed face. There are probably some cases like handling multiple members and members who only get halfway through the checkout that would need to be accounted for, but overall it would almost be so easy it'd be a bad business move not to tie member cards to facial ID. I thought that the targeted dynamic pricing model would be a complex piece of the pipeline until I realized that supermarkets already have a version of this in place in the form of targeted advertising and coupons. Coupons started unassumingly enough over 100 years ago, but have become highly refined and capable of precise targeting since the 2010s. That would be a great starting point for our model. We would just need to adjust it from running as a batch process for coupons to an online inference pipeline to handle streaming data. This is also a common MLOps task where the index face and shopper metadata can act as an online feature store, and we would most likely only need to account for different customer categorization strategies. Now, if we only had some way to get these price changes in front of our customers. In my demo, this was straightforward, but it gets more complex when you have thousands of ESLs. Luckily, the ESL system manufacturer has this covered and will integrate with the supermarket's ERP system, where we have already updated the sale prices based on our model. With this industry standard tech, we're able to create an end-to-end targeted dynamic pricing system. In-person stores were once limited compared to the fluctuating and opaque web storefronts, but new tech is giving in-person stores all the tools they need to copy the strategies of the e-commerce giants. In the short term, shopping at stores with no membership programs and minimal surveillance systems like Trader Joe's may be a good alternative. Long term, if we don't want to see this surveillance and tracking in our stores, then we need to be proactive about fighting for better data privacy laws. If you're not sure where to start, the Electronic Frontier Foundation and 404 Media do some great reporting on digital rights. Last year, a House bill was introduced in Colorado to prohibit surveillance data to set prices and wages, but was postponed indefinitely by the sponsors themselves. We have to contact our local representatives to support similar legislation that will protect consumer rights and push for more competition in the supermarket space if we want to say in how this plays out. The infrastructure is already in place, but it's not too late to combat the targeted and dynamic pricing future we're headed towards.